There we go. All right, we got everyone back, it looks like, warming up, huh? For Bernadette and all the folks over there in Boise, it is a chilly 60 degrees in here. So people are like kind of cold. I'm all right though, because I'm moving around, you know.
It's cold in this lab over here too, so I don't know if you noticed I put my
Okay,
hat
yeah,
on.
I see people got their hats on, so wow.
Yeah.
All right. Well, we'll survive this. We'll talk about cloud computing and GIS and get all excited about that topic, and we'll be all warmed up that way, right? Okay. The goal of this presentation is to describe and demystify this cloud. It amazes me how people somehow think that the cloud is this, number one, enormously powerful machine, right? And it's somewhere out there. No one really knows where, you know. It's something completely different, but it's not. Okay, so we're going to talk about what is it, how is it different from web services, and we'll talk a little bit about ROI and some TCO case studies. What is the cloud? Well, let's go through this and kind of have a little fake scenario here. Once upon a time, Sam the server man discovered that his servers were underutilized. To optimize their utilization rate, he made his servers available to others. This was really nothing new though, because ISPs, Internet Service Providers, not Idaho State Patrol or whatever it is, Internet Service Providers had been around for decades, right? But Sam's servers did more than just host HTML pages or act like an FTP site. They also provided infrastructure solutions. Hey, I got a server here, it can do whatever you want it to do. Or it can host services that his customers were not capable of hosting, right? So this commercialization of web services or web service hosting became known as cloud computing. There we go. There's a cloud. Oh, what's on behind the cloud? What goes on behind the cloud? Let's investigate that. Cloud computing, by definition, is on-demand, self-service services delivered in a metered fashion via a network, the internet, that's the network, using a multi-tenancy model within an elastic environment. Wow. We'll talk about all that big jargon here in just a little bit and take it from a 25-cent word and give you a couple of nickels and some change left over after that. Make it make sense. Terms. Virtualization. That's an important term. Now, this time when I taught IT4GIS, I think you probably have a better idea for cloud computers and virtualized computers because you were using one most of the semester. It was a private cloud, right? Virtualized machine. So similar to logical hard drives, which we talked about earlier, right, when we talked about RAID and all that, similar to logical hard drives, virtualization converts one server into many or more than one virtual server. Virtual servers, right? It's literally just one machine. So if I go like I did the other day, yesterday, when we're having some issues with ArcGIS Web Manager, the browser-based Web Manager, and I restart Fuji, well, Etna restarts too. It is one machine, right? That's just how it is. So at that point, hey, when we're doing restarts, power goes out, it's all out, okay? Nothing changes there. It is one physical machine made to act as virtual, numerous virtual machines. It requires a physical host server, a fairly new one, fairly large one, and a host operating system. In our case, we use Windows Server 2012, 64-bit, R2, blah, 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 plus virtualization software called the hypervisor and management suite software. Now, with Windows Server 2012 comes bundled when you buy the correct version of it, comes bundled with the virtualization software, which is what we did on that new machine. Multi-tenancy, that term that I threw out a little while ago, it's just like an apartment building, right? So here we have an apartment building, and we have multiple tenants living in this apartment building, or this condominium, right? Everyone, this is their house. This is their place. They can paint the walls as they want and so on and so forth. Because you got a good landlord, he lets you do that, right? And every one of them, you know, this is their place, completely separate, but it's actually inside one building. Okay, so it's one server with one physical server with lots of virtual servers. That's this multi-tenancy approach. And you can have a tenant on your cloud server that is NASA, another one is an insurance company, another one is me, you know, whatever. You can tell it to whoever you want to you know, give access to those clients. Elasticity, and sometimes I kind of chuckle because it's a new word for the same thing, similar to what's called scalability. We used to call it scalability. In the cloud world, they call it elasticity. All right, let's just see what this really means then. So these couple graphs here are from Amazon. Amazon's probably the leader in commercial cloud services. The folks that I work with at Goddard Space Flight Center, NASA, is a big client of Amazon Web Services. Esri is a big client of Amazon, so you know it's probably the leader in this. What we're looking at here is time, let's say over some years, maybe 5-year, 6-year time period, let's say. And here's computing power for an organization. We look at this graph over here. The red line in both cases is actual usage of computing power. The blue line is planned capacity. So when we first start up, we buy one server because we don't have much going on. This is a small couple of projects. But then maybe we land some bigger projects at the research center. We got some more work going on. And pretty soon, hey, we have outpaced our capacity. Everyone's got to kind of scale back. Okay, don't run that job now. Wait till this one's done. That's not very productive. But we got to do it because we don't have enough servers. But I got some servers on order. Okay, I've ordered 4 more servers. Oh, they just came in. Wow, we're in good shape. Right? And we're in good shape for a while. Uh-oh, hold on. I may have to buy some new ones here. Oh, but hold on. That grant just ended. We're fine. We made it to the end. So we don't have that much to do now. Wow, I'm fine. I'm just good. But oh, I got another grant coming in. I got awarded it. We can't start work for a little while, but I know we're going to max out. So I'm going to buy 3 more servers. Okay? And oops, I didn't know this, but oh man, this is more work than I thought it was ever going to be. And now we got to start taking turns using the computers again. Things aren't going well. So what you see here is here we have wasted capacity. We have these servers that are doing nothing. Right? And over here, we have customer dissatisfaction. You're waiting. Come on. And not even customers. In some cases, it'd be the research analysts in this sort of scenario. I can't get my work done because I can't get on the server. Or because I can't get onto the geoprocessing server to get it done. I can't get my time in there. I can't get enough stuff into the queue. It just sits there forever, never gets processed. Those sorts of things. So you can see that this example here in a traditional data center doesn't work too well. You have a lot of waste and a lot of this dissatisfaction. You can't respond quickly enough to match what this actual need is. Then here we have Amazon Web Services to the rescue. Wow. Now, of course, understand that these guys are marketing. Okay, there's a little bit of that in here. Okay. So what we have here again is red line is actual usage and blue line is capacity. Notice that the blue line is always just above the red line. And how is that? Well, there's an algorithm written into how Amazon sells their services that as you approach what you're currently paying for, right, and as you start pushing, oh, he's starting to need more, he's using it more, we're going to give you more. Okay? And then I'm not processing too much, so they scale it back. right? This model is nothing new. You do it all the time. How many folks have Idaho Power or some sort of electricity in their home? Sure, that's what that is, right? That's what that is. You're paying on a metered fashion. So you plug that thing in, right? You know, you don't have to call up Idaho Power and say, send me some wattage. How much you want? I don't know, 500 watts. Okay, coming your way. And then you're going along for a while and all of a sudden, it's gone. Damn, come on, I used all my wattage. I better call them up and get some more. No, that's not how it works, right? The more you plug in, the more you get, the more lights go on in your house, and so does your bill, right? Exactly the same here. So nothing phenomenal about it. You need more, they give you more, because they have these resources at hand to allow you to have more, and keep giving you more, give you more, give you more. There's some cloud deployment models we should be aware of. One is the private cloud. That's what we're doing here. It's on-premises, it's internal. And then there's the public cloud, off-premises, external. Things like Big Map services, ArcGIS online services, Amazon cloud, happening in Amazon's cloud. Some folks do what's called a hybrid approach to their cloud deployment. It's also called partly cloudy. We'll talk about that in a little bit, what the differences between, I guess. This is a hybrid approach. We've got some private cloud resources. We've got some public cloud resources. And that's kind of what we're doing here now, starting this year, with that machine, plus the stuff that we do on ArcGIS Online, the NASA stuff that we're doing in Amazon over here in the public cloud. That's a good approach. Nothing wrong with that. The hybrid model can be clear. You're not doing anything in the cloud. It's all just straight up servers. Servers, workstations, whatever. Or it can be 100% in the cloud. Hey, we sold off all of our servers. We're doing everything in the cloud. Or it can be a partly cloudy approach. And you can do stuff just on regular servers. They don't have to be all virtualized servers. And that could be on the clear side there. So what services are offered in the cloud? If it's not just HTML hosting to make a nice web page and those sorts of things, what services are offered? You may have seen a couple slides ago that these little acronyms started coming out. SaaS, PaaS, all the AASs. And notice how it's always written with a capital letter to start it off with, 2 small a's, and then a capital letter S. Okay? That is as a service. That's all it is, as a service. We start off on the bottom of this list here. We can contract with Amazon. Actually, we could contract with Amazon for any of these things, all the way up, because they offer so many different packages, I guess you'd say. We could do infrastructure as a service, IaaS. All we want is a server. And Amazon will sell you a server, right? Virtualized server. You sign up for whatever their time period is, and then you can install ArcGIS or server on it, right? That's your license, and that's your server. It's just as if it's sitting here. You can do that. Then we have PaaS, platform as a service. This is an application platform or middleware as a service on which developers can build and deploy custom applications. Adobe Flex, when you actually program flat out, you don't use the ArcGIS for Flex. If you don't use that tool, you could actually go straight to the Flex environment, the Flash environment, and you used to buy this software, this language, the programming language, and you'd install it on your machine, just like you would install Microsoft Visual Studio, and you start programming on your machine. Well, now Adobe has changed that model to be a cloud deployed model. This platform as a service, okay? You go ahead and you subscribe to Adobe, what do they call it? It's a whole suite of their software, their programming languages, Flex and Flash and so on and so forth. And then I could sit here, log into my Adobe, just like we're doing Adobe Connect, I would log into Adobe, whatever they call their, their software suite, and I could do my programming here, save all my applications. I could then go home, right, or to another computer and log back in, and it's just where I left it. I don't have to, oh yeah, I got to copy my files across and take them home now to work on. No, everything's stored in the cloud. That's this platform as a service. One example of it. Then we have SaaS, and there's a lot of these out there. This is end-user applications delivered as a service rather than on-premises software. Microsoft wants to go that way with Office 365, or whatever they're calling that thing now. Software as a service. We use Adobe Connect, that's that thing right there, SaaS. We use ArcGIS Online, that's I think would be considered an SaaS. Software as a service. WebEx, some folks use that. I have used that. Gmail, I mean, that's what ISU uses for their email client, is Gmail. That's software as a service as well, and lots of other things besides the mail. For GIS Day, we put together a little video, kind of fun thing we do the last couple of years, and the software that puts that together and does all the music and mixing and this doesn't exist on my machine. That's Animoto, and that thing exists in the cloud. Okay, I just say use these images, yeah, that music sounds fine, do it. And they put it together, right? And I say, I don't like how it turned out, try something else. I make some tweaks to it, whatever. So the software, again, doesn't exist on my desktop, doesn't exist anywhere on my machine. I simply use that service called Animoto, and that's another example of a cloud-based software as a service. Where does GIS fit as a service? What do you think? Brainstorm some examples. I kind of alluded to some already. Anyone? You can read ahead a little bit. Okay. Software as a service. We have Arc Logistics Online, Business Analyst Online, Community Analyst Online, which is not on the list, and ArcGIS Explorer Online, which I believe ArcGIS Explorer Online is going away. They're going to get rid of that thing, I heard. Platform as a service, ArcGIS Online is platform as a service, ArcGIS Web Mapping Services, blah, 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 lots of things, right? How many folks have used either Business Analyst Online or Community Analyst Online? That's some powerful software, I tell you. I was putzing with Community Analyst Online, working with some health folks over here, and they said, what kind of information can we get? I said, well, we can get all this census information that tells, the breakdowns in the census blocks and the census tracts about age ratios and some racial information and all this good stuff. And is that all we can get? I said, well, let me check. So I went to Community Analyst Online, and I zoomed into a part of Pocatello and clicked a little polygon around it, the neighborhood, just pretty much random, And then I clicked on Give Me Reports, something like that. And all these different potential reports came up. I swear there was 20, all these different types. And you click on one to read the description of what you'll get. So that sounds kind of interesting. I chose 3, 4 of them. And one of them was called this Community Fabric, or Community Tapestry. And the little description sounded interesting. So, if you use your credit card and if you fill out lots of forms and surveys and stuff, the long form of the census, that information goes somewhere. And apparently, some of these third-party contractors that take all this data and then resell it, and they crunch it and resell it, Esri has purchased, obviously, some of that stuff and made it available through Community Analyst Online. So by doing that, I could see that X percentage of people in this neighborhood belong to gyms, like Gold's Gym, X percentage buy vitamin C supplements, X percentage do this, X percentage do that, and X percentage subscribe to these type of magazines. Oh my gosh, So I was tempted, I should go by my house, just a little tiny polygon, and it'll say, 33% of the people are named Keith. right? Oh my gosh, it was crazy. I couldn't believe the kind of information that you could get from community analysts online, business analysts online, and those sorts of things. That data that, has been accumulating for years through, watching, your credit card spending habits and how you fill out surveys and all this different stuff, the magazines you subscribe to, it goes somewhere, all right? And one of the places that, one of the end users, I think, is community analysts online, Esri stuff, that's then being used to analyze, market stuff and whatever. That was kind of weird. I thought that was kind of weird. I'm getting old, I just think that's kind of different. So how does the cloud differ from web services we already learned about? I need you guys to brainstorm some. Maybe this will warm you up. Did you know that the brain is the most energy consumptive organ in the entire body? Uses energy like crazy. So if you use that energy, the idea is it's going to warm you up. So you got to get those, to get those neurons flowing, okay? And did you know that the brain only uses straight sugar? Straight sugar. So, bring yourself a little bowl of sugar and start eating. Fast energy. Now, I'm joking, people. Don't really do that. Oh, my gosh.
No way, that's why the Snickers commercial is like.
Is that it? We should go do a deep fried Snickers. Wow. Isn't that something?
Diminishing returns.
Yeah, right. This is too much. It overloads you. You flop over on the floor. That's not good, huh? Okay, come on now. Brainstorm this. How is it different from the web services we already learned about? If I just go onto one of my servers and I create a web service for NAPE aerial imagery, am I in the cloud? It's a web service, it's a service.
It's a type of cloud, yes.
Is it a cumulonimbus cloud?
Yeah. No. No, my servers, the big production servers, AGS and NAPE, they're not the cloud. Right? Because they're just standalone servers. They don't follow the multi-tenancy approach. They're not virtualized in any way. Right? They're absolutely clear, not cloudy at all. If I build those services there on Fuji and Etna, same service, am I now in the cloud? Yes. Because that's a virtualized server. It's a private cloud. So is there really any difference in the service? Is it better?
Well,
no.
Wouldn't a true cloud be like, I guess, more resilient to failure? Like if a part of it fails, it can recover from that in real time, whereas if that server back there goes down, it's
no, not really. See, the cloud definition is what we talked about earlier. Okay?
Yeah.
Now then, what you're talking about gets into the particulars of what your contract is. Okay? And we'll talk about some of those things in a little bit, called the SLA, Service Level Agreement. Now, when you get into that, you might have questions about power outages, right? And those sort of things. So you can get some really, really cheap cloud resources that happen to be outsourced in India, where blackouts are like a daily thing. Literally. I mean, I had grad students and postdocs that worked for me, and they were like, wow. When they first would come here, it's like, hey, your power never goes up. Oh, no. Oh, yeah, but in India, it goes up at least every day, And they've come from pretty big cities. So there's issues that you might have with the company that's providing the cloud services. Officially, it is the cloud. That's officially the cloud. If I was very, very worried about the 5.9, we talked about a long time ago, what we'd have is we'd have distributed this across, mirrored it across. So if one goes down, it automatically fails over and jumps onto another server. No one knows that you're actually on another server because it's all your data copied across in real time, so on and so forth. That's what Amazon's doing, and that's what you're paying for, right? But it's in the cloud. You're in the cloud here, Fuji Etna, right? Because by definition, it's a virtualized server, multi-tenancy model, blah, 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 right? And we can scale up. If we wanted to, we could get real fancy and scale it as more people need it. It changes the number of cores available to you. Some people noticed and reported to me that they're on Etna, they were having some problems. It was kind of getting slow. So I told Kendra, I said, hey, we're having problems. How many cores did you give that thing? She said, oh, I'll just make a change. So from her machine there, She just changed the number of cores available to Aetna, and then, oh, it's working fine again. And in fact, one of my students, Richard Powell, who's in Idaho Falls, he said, hey, I checked the number of cores to set my services, you know, remember that one step of the number of instances it should run? And the first time I sworn it said, you know, X number of cores is available, but now it says this. Which one's right? I said, yeah, we just upped it. You see, so definitely that's cloud. See?
So how come, I don't know, like, these things have a whole bunch of wasted computing power. They're just sitting here showing pictures to us right now.
Yeah.
So how come we don't just have, like, you know, a resourceless shell, basically, that we're logged into, and have that thing communicating with the server that handles anything that we do?
Yeah.
How come we don't do that type of stuff?
That's the mainframe approach. That's like 30 years old, right?
Yeah, but
the thin client.
It's in electricity here.
Yeah, I actually wouldn't doubt that we're going to return to somewhat of a thin client approach in the future, where your software is in the cloud.
Right.
Right? Your data is stored in the cloud. Right? And that's where Microsoft wants to go, because it's going to be really, really darn near impossible to pirate their software. So they're losing money with that. And yeah, sure, for energy consumption, if you have a thin client, all it is essentially a monitor and a means to get on the internet. That's about it.
Yeah.
That's huge differences. And I wouldn't doubt that in the future that's kind of the approach it's going to go to, where in GIS, data is sitting on something like IBM DB2, on that machine, or on whatever machine, right? And then you get to your data not on your hard drive, but you get to the data as services streamed in, you know, or data that sits on servers. Go ahead.
Is that kind of how, like, the Chromebook works, where, you know...
I don't know much about Chromebook. I was in Staples the other day, and I saw this Chromebook thing advertised. I didn't take much of a look at it, so who knows much about Chromebook? That's Google's thing, right?
It's all the Google ecosystem, and anything you do is a Google app. You know,
Yeah.
like, whatever you can install on Chrome is what you can install on your computer. It's just Linux running Chrome solely, like in standalone mode.
I see.
That's I was looking at laptops a while back, and it seemed like they didn't really have a whole lot as far as, like, doing documents and stuff you could save on it, but it saved it to...
So you do the Google Docs, right?
So that's the thing, like, I mean, you don't need awesome hardware to do all this stuff. You can buy a top-line computer and just use it to look at PowerPoints or pictures, you know, and you're just wasting your money and stuff. So their idea is that, you know, if you need some computing power, it'll be done off-site, and that way you're not paying the overhead on your computer. But then, yeah, like, Microsoft Office is only available on Windows, so then they've got the Office Online now that you can access through a website. So you can access that from different systems.
Right. Yeah, I think that's the approach with that, right? Is it's which then is how much different is that from a tablet, you know? And
yeah, they're just aiming at the people that still like laptops.
Sure, sure.
That don't need like a lot of power.
Yep, that's right. So I think we're going to see more movement toward that way, not necessarily for the green side of it to save the energy, but to centralize where the data comes from. In the GIS world, you know, centralized data, think enterprise, remember that early on? For that whole approach, streamed in web services, those sorts of things, instead of put it on my hard drive, this is my data, so on and so forth.
Yeah.
That's definitely, I think, where it's going to go. So we have a good feel for what's the cloud and what's not. My main point is there's nothing so special about the cloud that if you put something in the cloud, it's better, it's faster, it's bigger, it's whatever. Okay? In fact, when I looked at some of the specs of the actual computer that I would be buying from Amazon, I'm like, I got machines way bigger than that. See? It's just that if I want more, I can get more pretty easily, just by saying, hey, you know, I just start using more, they'll give me more, and they'll build me more. See what I mean? But don't, that's the demystifying part. Don't think that just because something's in the cloud, it's going to automatically be faster, better, bigger, whatever. That's not really always the case. Okay? And the great example there is AGS machine, NAPE machine sitting in there, standalone servers, big machines. Fuji over here, right, dozen cores on this thing. That's the cloud, that's not. Is the service coming from any of these any better? No.
But, you know, the one thing that kind of sucks about cloud computing is you're at the mercy of your internet connection. You know, if that thing is intermittent or slow,
Yes.
so is everything else.
Oh yeah. Yeah, what did I say early on? About week 1, 2, the bottleneck is the network, and it probably always will, because we're putting much more reliance on everything that we're doing, right, on the network. Everything's going to be on the internet. I mean, years ago, right, it was data, right, either for GIS, it's data files, it's emails that are flying through the internet, right? Well, now hold on. Now all of a sudden we've got YouTube sitting out there, and Netflix, and Vudu, and Amazon streaming video, and all that stuff's going over the same network lines. Now we also want voice over IP, right? So now all our telephone calls go over, you know, if you do that, or eventually probably will be, no matter what, doing that. Now that's all the more stuff trying to fit through that same pipe. That's why the pipe's got to keep getting bigger and bigger and bigger, and we will keep filling them up. The faster, the bigger they make them, we'll fill them right up. That's just it. We're trying to do, I think, probably too much, and that's why a lot of companies have invested money in broadband wireless. Right?
Even that's limited, right?
Don't get started on Light Squared. You guys heard of Light Squared years ago, right? A couple years ago. That was a bad deal. It almost happened, you know. So everyone feel pretty comfortable with this stuff? Cloud versus clear, right? Let's talk about ROI and TCO. TCO is what again?
Total cost of ownership.
Total cost of ownership. ROI is?
Return on investment.
Return on investment. Okay, so case study number 1. A small Idaho county wants to make GIS maps of the county available via the web. They aren't doing anything on the internet right now. They don't even own a server. They got one GIS person, that's their GIS shop, that's their GIS department. They're getting fairly frequently these requirements from the federal government, census and all stuff, to do GIS stuff. Send us this in GIS format. So they say, okay, we got GIS stuff, but now the people who live in our county, they want to see a map. Oh my gosh, we better do something. What should they do? What would you, if you were a consultant, you were asked to consult with them, what would you say? Should they go with buy yourself a server, ArcGIS for server, invest in, tell Quest or CenturyLink to run some good fiber up to you and in the ground and do all this stuff? Or should you tell them invest in cloud-based resources? For case study number 1, what would you do?
You want to look at both, right?
Sure, you want to look at both, but just what's your gut feel?
Cloud.
You're saying cloud? Yeah, Colton says cloud, right, Colton? Yeah, I agree with you.
Maybe. How many users are going to be accessing it?
How big is this county?
Huh?
How big is this county?
Oh, I'm making it all up, It's a small Idaho county, right? But they feel like they got to do that, right? That's what they got to do.
So like a private cloud then? Would that be?
Well, if you do a private cloud, you still got to invest in the servers,
Right.
the rack, the cooling, the internet connectivity, right?
Are there any, open source or free alternatives to Arc server?
There's some open stuff right there. Yeah, sure.
Just for, small implementations?
There are, but those tend to be very difficult, right? And what ArcGIS Online has done is made it really easy, really, really easy to put your stuff out there and connect it all up, So if I was consulting with those folks, I would have them look very, very seriously at purchasing Amazon type of services, okay? Because all you got to do is get your data out there once, right? And if it changes, okay, do push however often you want to, right? Push it back out there. Then it's their network, right? It's their servers and all this good stuff like this. And you don't have to worry about how fast your server is. You don't have to have a server, right, at the office. So that would, my gut feel was that would be the way to go. Case study number 2 is a little bit different. A large research university wants to make GIS maps available via the web. Large research university. We could probably assume they've got good network infrastructure. They've probably got a data center, right? Racks of servers, right? What do you think? Should they invest in, just trash all those servers and invest in cloud? Push all the money, everything's going to the cloud now?
think you have more control over like your resources and stuff in that case, so it'd probably be better just go custom.
In-house.
Yeah, in-house.
Yeah, I'd agree with you, right? I looked into, instead of buying a new server that we bought not too long ago, just for hard drive space, I said, how much would it cost me if I just buy the same hard drive space out on Amazon, right? And I did all the math on it. Holy smokes. It'd cost me like, what was it, $5,000-$6,000 a year. Holy smokes. I can buy that computer, one-time purchase. I got rack space, I got electricity, pop her in there, right? I'm done, right? Because otherwise, in year 2, I got another $5,000 to pay for it, right? So sometimes it's not going to work. If you've got the infrastructure in place, you may be better off. Now let's also talk about total cost of ownership. If Dell charges me $5,000 to buy that machine, what else is it to that big picture, though? What else am I paying for?
Oh, tech support,
Maintain that machine.
Well, no, that's $5,000. That's all paid for by the $5,000. But we got to think total cost of ownership. I got that thing here now, and it's in a box. What do I do now?
You need to use it.
Huh?
You need to use it.
Before I can use it, what do I got to do to it?
Take time to set it up.
Who's going to do that?
Find somebody to do
oh,
it.
maintenance.
Maybe your
Well,
system.
I've got a sysadmin I'm paying,
Yeah.
right? That's part of it. That's total cost of ownership. Okay, that sysadmin or a technician or something like that is going to take that thing out of that box, install it in that, and spend some time getting it up and running. And then make sure it keeps running, right? Make sure that the service packs are on it, it's patched, it's updated, it's functioning correctly. Got to worry about security, breaches, all this good stuff. And someone's going to be babysitting that for part of their time. I got to include that total cost of ownership. So for long term, right, you may see that, oh, it's not too much. As cloud prices come down, right, we may see at a certain point in the future that it will be beneficial to start dumping existing servers or just let them die and don't buy new servers and start pushing resources to the cloud. Okay? Because one thing about hiring people is it's very different than a capital expenditure of equipment. It's a long-term expenditure, and people are very expensive. You got salary, health insurance, fringe benefits, and in fact, the way health insurance is going today, for people who are working at about half-time, I'll spend more on health insurance than I'll pay for salary. You know? So it's like crazy, crazy. And people are worrying about that, right? People who are hiring and all this good stuff like that are worrying about those sort of things. And it goes into TCO. And we got to worry about those sort of things. We got to be concerned with that sort of stuff. Okay? So, as those cloud prices go down, we're going to constantly reassess and see where we're going to go with new servers. We may start not replacing servers in the future. I don't know. But I wouldn't doubt that that's how it's going to be. So there's a partly cloudy approach again. Gartner Group came out with this saying years ago, own the base, rent the spike. Own the base, rent the spike. Here's my servers. This is what they can do over time. Right? I have a quantified number of servers. You guys saw them in the tour, the YouTube tour, whatever. You saw them. That's what I can do. And eventually I'll fill up my rack. I'm not going to buy another rack. Okay? And this is my line right here. But if I have a project that comes in for whatever it is, you know, a research grant or some sort of contract to do some work, what I might say, I'm not buying another server. I'm going to write into the contract money for servers, but they're not going to be on site. I'll buy Amazon. And then, whoops, you know, I just lost, that one grant just expired and didn't get another one in. That one just expired, you know, it's kind of in a dry spell here, so we're fine. I don't have a bunch of servers sitting out here not doing anything. I can just work with baseline. That's my base. This is the spike. Good approach. Real good approach to handling, you know, especially in the research world or in many, many cases the business world the same way. Spikes in activity. Look at now, right? A lot of companies, retail companies, do 60, 70, 80% of their business now, right? So what do? For employees? They hire seasonal. Hey, They're renting the site, right? And then they got their full-time employees here that are running the 20% or whatever it is year-round. Okay, same approach. Considerations, people are not using the cloud. Why? Why are people not using the cloud? Well, let's look at some of these slices of the pie. Fear of loss of control of data. Hey, didn't we visit this before? Remember when I talked a long time ago about people, their worries about putting data out on a website in the first place? Remember, it's my data. They don't. You're not going to do it my way. You know, we got all these specialized things. That's the exact same thing happening all over again with the cloud. Fear of loss of control of data. Some of it's pretty well justified. Others it's an excuse. Fear of unauthorized access to customer information. So there's some fear factors here. Features and general maturity of the technology. This one is going away rapidly as Amazon is really showing that their machine, their whole service is very robust. It's good stuff. And not so maybe for some others. Security defects in the technology, unpredictable costs. Again, I think that as this whole cloud world, if you want to call it that, matures, that these costs are not unpredictable anymore. You know what you're getting into just by looking at that contract. Business viability of the provider. Are they going to be around next month? Amazon, yeah. Joe's Happy Cloud, probably not. You know? Vendor lock-in. Hey, you signed this contract. The tiny little print says you're with us for 10 years. Whoops, that's no good. Application of system performance. Hey, it doesn't really work any better than my old server here. I'm disappointed. And then there's various other reasons. A lot of this stuff, a lot of this pie comes down to what's called a service level agreement. Right? Looking at, AKA, the contract, understanding what you're getting and getting it spelled out correctly. The federal government right now does use cloud services, right? Amazon, those sort of things, but there's a stipulation in their SLA that says that their data can never go on a machine that doesn't physically sit in the United States. Amazon can't, you know, buy a bunch of servers for cheap electricity in India, right? Cheap, cheap, cheap. But they go down every, couple times a day, right? They can't, the NASA's data, whatever, can't go sitting over there just because that's written into the SLA. If someone else just came in and contracted with Amazon and didn't have that in their SLA, sure, it could go over there, right? You may not be happy with it, or you may not know any different. It may not be a big deal to you. So physical security is another concern, right? Who can actually physically touch that machine? Because if they can physically touch it, they can physically steal it, right? They can physically destroy it, all that good stuff, right? So is your data center secure? And there's standards, military type standards, federal standards, those sorts of things. And for many, many folks, this is a big concern, right? People can physically go in and just take the thing. And that's not good. Cybersecurity, geographic location we already talked about, privacy, availability, HIPAA, compliance, Sarbanes-Oxley, all these regulations that people need to be worried about. And you know what, though? This really is not just a concern for cloud, right? It's a concern for all servers, right? For all data centers, physical security, cybersecurity, HIPAA, Sarbanes-Oxley. It's for, not just cloud. When they came up with this list, they said, hey, this is for cloud. And then they said, well, hold on, I guess it's not just for the cloud, it's for everybody, right? So we look at that sort of stuff, and that the door to our server room is always locked. Very, very few people have access to that thing, keys to it. So we have pretty good physical security. Cyber security, you got your ISU's firewalls and so on and so forth. So we're pretty good that way. And geographic location, sure, we're sitting right here in Idaho, heart of America. So yeah, good stuff. Important things. Any questions on the cloud?
Keith, I got a question.
Yes, go ahead.
I guess from a consumer's point of view, you know, there's always that scenario in which, you know, you face a bankruptcy scenario and you can't pay for your data storage anymore, your processing. I think that'd be I don't know if you touched on that very much in that pie diagram, but that seems like that'd be another concern. You know, can I pay for this the entire year? You know, what if I need to pay for, you know, a court battle, something like that? It seems like another scenario which, from a private contractor's point of view, that might be relevant.
Right. So are you saying the concern is that the company you're contracting with might go bankrupt, or you, the person who's contracting, wouldn't have the money to pay for the cloud services suddenly?
Yeah, what if you're like obligated to maintain a certain number or a certain amount of data for referencing back to, and all of a sudden you can't afford that data storage capacity?
Oh, okay, you can't afford, right. Yeah.
Right.
That's almost the flip side of its business viability of the provider. And I guess, you know, certainly if you have your own hard drive sitting at home or sitting wherever in an office, you put your data there, you know, it's not going to mysteriously disappear because you didn't pay a bill, right?
Yeah.
The data is still going to be there. And so if there's those sort of concerns about paying the bill, what's going to happen to my data, you'd certainly want to look very closely at that SLA and see what happens if you don't, you know, pay it. Are they just simply going to close that account and delete your data? Or, you know, would you have a certain amount of time to move that data back off to a local type of machine? Now, again, it would be an SLA type of service level agreement type of question. But it's a good point. Anything else? Any other questions? Here in Pokey or any of the folks there in Boise? Feel pretty comfortable with the concepts? The only homework for the cloud computing is just some reading type of things. Some of it's optional readings. Others I'm calling it that's your assignment to read it, which means that you know, it could appear on the final exam, right? That's all fair game. Anything that's considered an optional reading will not appear on the final exam. The only thing that you have an actual something you need to turn in to me is for the HPC stuff, the little experiment or whatever you want to call it you're going to do with Mr. Shorty, the Linux machine. I had Brock run through it, and I think he said he finished it up in about 20 minutes, so it's not a very big assignment. I don't know how familiar he is with Linux, though. So if you're not at all familiar with command prompt, it may take you a little longer. But he had no problems with it. I was worried with some of those DHCP problems that we've been having, and you know, the network firewalling. I was worried that you know, we may have trouble hitting it, but he was able to get onto it without any problems. So it should be a pretty smooth sailing for everyone. In that exercise that you're going to download for the HPC, there is a little README file, a text file called logins, and so refer to that for your username. The password is all the same, and that's actually given in the exercise Word document. Same deal otherwise, just follow it step by step and send it in to me before the class starts next week. And then I think probably tomorrow I'll send out that optional exercise on Hadoop, which is, a lot of it's just watching some kind of cool videos, I think, and I think it's kind of fun, just to have some fun with that, okay? And that will wrap it, folks. So